The Leaning Tower of Pisa is a very famous building known worldwide for its unintended tilt. It is located in Pisa, a city in Italy which is rich in history and culture. Construction of the tower began in 1173 during a time when Pisa was a powerful maritime republic. The tower was not meant to lean. The tilt began during construction due to unstable foundation soil. It was designed to be a bell tower, or campanile in Italian, to complement the nearby cathedral. It stands beside the Pisa Cathedral in Piazza dei Miracoli, or Square of Miracles, a UNESCO World Heritage Site. The tower is a stunning example of Romanesque architecture, featuring many arches and columns that add to its beauty. Made of white marble, it was planned to be about 56 meters tall, but its lean has made it even more famous. The builders wanted to create a magnificent structure to show the wealth and power of Pisa, an important maritime republic at that time. They succeeded, but not in the way they originally intended. Many people visit the tower every year to see its famous lean and admire its beauty. It has become a must-see destination for tourists from all over the world. The design is intricate and graceful, with 8 stories in total, each adorned with beautiful arches and columns. The top story houses the bells, which were meant to call people to the cathedral services. These bells add to the tower's charm and historical significance. The tower is more than just a leaning structure. It is a symbol of Pisa and a UNESCO World Heritage Site, representing the city's rich history and architectural prowess. The entire Square of Miracles is protected, including the cathedral, the baptistry and the cemetery. This area is a testament to the artistic and architectural achievements of medieval Italy. The tower represents centuries of history and human ingenuity. Its construction and subsequent preservation efforts showcase the advancements in engineering and architecture over the years. Its survival is a story of engineering skill and determination. Over the years, numerous efforts have been made to stabilize the tower and preserve it for future generations to admire. The problem with the tower started very early. Construction began on August 9, 1173, and work progressed for about 5 years. Builders finished the first few floors, reaching the 3rd story. The ground beneath the tower started to sink unevenly, causing the structure to tilt. The main reason for the lean was the poor ground, made of soft and unstable soil. The foundation of the tower was also too shallow, only 3 meters deep. When the lean appeared, construction stopped for almost 100 years due to wars. This long pause allowed the soil underneath to settle a bit. When work resumed in 1272, engineers tried to fix the lean by making the new stories taller on one side. However, this made the tower heavier, causing it to sink even more. Over the following centuries, the tower continued to lean more and more, defying the expectations of many who thought it would eventually collapse. The tilt became increasingly pronounced, capturing the attention of architects and engineers from around the world. By the early 14th century, construction of the bell chamber was completed around 1372. This addition was intended to enhance the tower's grandeur, but it also added more weight, exacerbating the lean. Engineers tried to correct the lean by angling the bell chamber to make it look straighter. Despite their efforts, the lean persisted and the tower continued to tilt, becoming a subject of fascination and concern. As time passed, the lean became more famous, and people were amazed that the tower did not fall. It became a popular tourist attraction, drawing visitors from all over who marveled at its precarious angle and the mystery of its endurance. Scientists and architects studied it, including Galileo Galilei, who supposedly used the tower for experiments. His work added to the tower's legend, intertwining it with the history of scientific discovery. The lean was a serious worry for city officials, as the tower was a precious monument. They feared that without intervention, the tower might eventually succumb to gravity and collapse, losing a significant piece of their heritage. Many measurements were taken over the years, showing a consistent increase in the tilt. These records provided valuable data for future efforts to stabilize the structure and prevent further leaning. By the 20th century, the lean was very noticeable, making the structure look precarious. The tower's condition prompted urgent discussions and debates about the best methods to preserve it for future generations. The authorities in Pisa knew they had a major problem and feared that one day it might simply topple over. They were determined to find a solution to save this iconic landmark, ensuring its survival for centuries to come. Throughout its history, there were many attempts to stabilize the tower. Builders added extra height to one side, hoping to visually correct the lean or shift the center of gravity. However, this only added more weight, often making the problem worse. In the 19th century, more ambitious interventions took place. In 1838, architect Alessandro della Gherardesca dug a walkway around the foundation, disturbing the water table and causing the tower to lean more. Another attempt involved injecting cement grout into the foundations in 1934, ordered by Benito Mussolini. Workers drilled many holes into the foundation and pumped in tons of concrete, but this spread unevenly, making the tower tilt more. These early attempts often lacked a full understanding of soil mechanics, creating new problems or accelerating the existing lean. By the late 20th century, the Leaning Tower of Pisa was in serious trouble. The top of the tower was leaning about 5.5 degrees, a very dangerous angle. Engineers worried that it was close to its tipping point and the structure was under immense stress. The Italian government became extremely concerned and made a public appeal for help in 1964. Many suggestions came in, some practical and others quite imaginative. In 1990, the tower was closed to the public, marking the beginning of a serious effort to stabilize it. An international committee of experts was formed to find a way to save the tower. They needed a solution that was both effective and respectful of the monument's history. The goal was to reduce the lean slightly, bringing it back to a safer angle. The task of saving the Leaning Tower of Pisa was a global challenge. The Italian government appointed an international committee led by Professor Michele Jamiolkowski. The committee included experts from many fields, bringing diverse knowledge and perspectives to the problem. Their first priority was to prevent an immediate collapse, so they placed lead counterweights on the north side of the tower's base. This temporary measure provided some stability, giving the committee time to investigate and debate. After much discussion, the committee agreed on a final solution: under excavation. This method involved carefully removing small amounts of soil from beneath the tower, causing it to rotate back towards the north and reduce the lean. Understanding the soil beneath the Tower of Pisa was key. The problem was not the tower itself, but the weak, compressible ground. The soil in Pisa is a mix of layers, including soft clay, sand, and silt. Engineers conducted extensive soil investigations, drilling boreholes and taking samples for testing. They learned about the soil's strength, compressibility, and water levels. The soil profile showed 3 main layers: a top layer of soft estuarine deposits, a layer of denser marine clay, and a layer of dense sand. The tower's shallow foundation rested mostly on the upper soft layer, causing the settlement and lean. Engineers created detailed computer models to predict how the tower would react to different intervention methods. The under-excavation method was chosen because it was gentle and allowed for very precise control. The chosen method was soil extraction, also known as under-excavation. This was a very careful and slow process, removing small amounts of soil from under the north side of the tower's foundation. By removing soil from this side, engineers hoped it would settle slightly, causing the entire tower to rotate back towards the north and reduce the lean. Engineers used special drills encased in housing to prevent cave-ins. The process was extremely gradual, removing only a few tens of liters of soil per day. The tower was harnessed with steel cables attached to large A-frames as a safety measure. The work began in 1999 and continued for several years, done in carefully planned phases. Engineers monitored the tower's response constantly, using an array of sensors to provide real-time data. The soil extraction project was a great success, marking a significant milestone in the preservation efforts of the Leaning Tower of Pisa. This intricate process involved carefully removing soil from beneath the tower to reduce its dangerous tilt. Over about 2 years, from 1999 to 2001, the tower responded as hoped, rotating back towards the north. This gradual adjustment was meticulously monitored by engineers, ensuring that every movement was within safe parameters. The lean was reduced by about 45 centimeters, bringing the tower back to the inclination it had in the early 19th century. This significant reduction not only stabilized the structure, but also preserved its iconic tilt, which continues to fascinate visitors from around the world. The tower was no longer in immediate danger of collapse. Structural engineers conducted thorough inspections to confirm its newfound stability, allowing the tower to safely welcome tourists once again. In December 2001, the Leaning Tower of Pisa was reopened to the public. The reopening ceremony was a momentous occasion, celebrating the successful efforts to preserve this historical landmark. The lead counterweights and steel cable stays were removed, and the tower stood freely, still leaning but much more stable. This marked the end of a critical phase in the restoration project, symbolizing the tower's resilience and the effectiveness of modern engineering techniques. The project ensured its survival for at least another 300 years. Engineers and preservationists continue to plan for the tower's future, ensuring that it remains a safe and cherished monument for generations to come. The tower is still monitored closely with a sophisticated system of sensors tracking its movement. These sensors provide real-time data, allowing for immediate response to any potential issues, thus safeguarding the tower's stability. The story of its rescue is a testament to modern engineering and the power of human ingenuity. The collaborative efforts of experts from various fields have ensured that the Leaning Tower of Pisa continues to stand as a marvel of historical architecture. The tower stands as a reminder of history and a treasure for Italy and the world. It continues to attract millions of visitors each year who come to marvel at its unique tilt and the incredible story of its preservation.